Hello everybody, my name is Muhammad Taqiya Hassan and I'm from the channel One Math Army. I'll be your maths mentor. Here I teach maths from first class to 11th class, and I teach some topics in 12th. I am mainly concentrating on 9th, 10th, 11th and 12th. I'll be teaching IGSC, ICSC and IGCSE from 10k subscribers. So, and now in this session, I will be discussing about sequences and series, which is 11th class topic. Now, let's right head into the topic. Now, sequence as and series. So, first of all, what is a sequence? A sequence is an enumerated collection of objects in which repetitions are allowed and order does matter. So it's a enumerated collection of objects. So it's a collection of objects in which repetitions are allowed. Like 1 1 1 1 is also a sequence, and order does matter. So I have this sequence over here, 1 4 7 10. I can't write it as 7 4 10 1. It would make just no sense. So it should have an order and the repetitions are allowed, but I'm not mentioning here that it should have a pattern. That's why here it's not a common difference, it's a difference. This sequence has a difference of 3 between each number. So 4 minus 1 is 3, 7 minus 4 is 3, and so on. Now a series is defined as the sum of the element of a sequence. So if you add this every term in this sequence, it will become a series. So in here I'm taking a sequence 1 2 3 4 5, and I'm making it in the series 1 plus 2 plus 3 plus 4 plus 5 equals to 15. Now this is an example of a series. Now progressions and sequence are mostly taken as the same, but it is not. They are different. I mentioned you earlier that sequence does not have a specific pattern, where progression does. That's why we hear arithmetic progression and geometric progression. They all have a pattern in them. Like this has a common difference, this has a common ratio, and so on. Now these are the types of progressions. We have 4 types of progressions: arithmetic progression, geometric progression, harmonic progression, and arithmetic geometric progression. Now in this session we will be mainly focusing on the arithmetic progression. Now let's start it. Now, arithmetic progression. This is the general way of expressing arithmetic progression. So there should be a general way of expressing everything. So we are going to express this arithmetic progression in a general way. Now the general way of expressing this is a plus d, a plus 2d, and I mentioned earlier that in arithmetic progression there should be a common difference. Like t2, this is t means term, and the number after I say is the nth term. Like tn is the nth term, t1 is the first term. Like t2 minus t1 should be equal to t3 minus t2. So if a plus d minus a is d, and a plus 2d minus a plus d is also d, like it should be satisfying from up to a to a plus n minus 1 into d. Okay, now a plus d, a plus 2d, and so on, a plus n minus 1 to d. Now how come we got this a plus? How did we get this thing? In the first term, the coefficient of d is 0. There is no d. In the second term, the coefficient of d is 1, 2 minus 1. In the third term, we have the coefficient of d as 2, which is 3 minus 1. In the fourth term, we have the coefficient of d as 3, which is 4 minus 1. Then in the nth term, we should have the coefficient of d as n minus 1. So that's a general way of the nth term formula we got here. And we have another one like the sum of the terms. These are the general formula. Like this is the nth term formula. Tn equals to a plus n minus 1 to d. And the proof is if the first term was a plus d, then the formula would have been a plus nd. But the first term is a, so nth term is a plus n minus n, a plus nd minus d, and you take this d common out of the last two terms, and you get a plus n minus 1 to d. Now this is important sum here. It will come in most of the problems and questions. You can use this. Like the sum of n terms, the sum of the first n terms is n by 2, number of terms by 2 into 2a 2 times the first term plus n minus 1 into d plus number of terms minus 1 into the common difference. Now let's prove this thing over here. So our AP, let our arithmetic progression be like a plus d, a plus 2d, a plus 3d, and so on, a plus n minus d, n minus 1 into d. So this is our progression right here, and the sum of this sequence will be a series, and that is a plus d plus a plus a 2d plus a plus a 3d plus a plus 4d, and so on. Now this is the last term over here. The nth term here is the last term. A plus n minus 1 and d is the last. So I'm just represent that with L. So instead of this, I am writing L, and the term before it, that's the last but one term, that will be L minus d, and the one before it will be n minus 2d. So just writing like a plus d plus a plus 2d plus a plus 3d, and so on, plus L minus 2d plus L minus d plus L. That's our first equation, and that will be represented by Sn, which is the sum of our sequence or series. Now I'm gonna reverse that thing. So all the terms are the same, but the order is different. So obviously the sum will be the same. So Sn again is L plus L minus d plus L minus 2d plus L minus 3d plus L minus 4d plus a plus 2d plus a plus d plus a, and so on up to here. Now we're gonna add these two. If we add these two equations, like the first equation and the second equation, we're gonna get 2 times the sum of these terms, like 2 times the series, equals to, all the d's cancel out. Like here you get a plus l, dd cancel, a plus l, 2d minus 2d cancel, a plus l plus l, and you're gonna get that n times. So we can write 2 into the series equals to n into a plus l, and hence our sum of n terms will be n by 2 into a plus l. So this formula can be used when the question is related to the last term and you're knowing the last term. So either this can be used, and if you just expand it, like we took the value of L as this thing over here. Now just take this value again and keep it in the value of L, and you're gonna get the same formula that we discussed over here. Like you will go like n by 2 into a plus n minus 1 into d, and here if you simplify that, we get n by 2 into 2a plus n minus 1 into d. So hence we prove that, and remember that L is the last term. Okay, now we come to the properties of the arithmetic progression. So there are 6 properties, and the first one is like, if a constant quantity is added to or subtracted from each term of an arithmetic progression, then the resulting terms of the sequence is also an AP with the same common difference. So let me just take a series over here, our example series. Okay, that would be a plus a plus d, a plus 2d, and so on, a plus n minus 1 into d. So this is our little series or sequence here over here. In that, we're gonna add a constant quantity, say k. So I'm gonna add k plus k plus k plus and k plus. So this is our series over here. This is our new sequence. Now in this, if you can see that the second term minus the first term is d, so it still have the same common difference. So we know that the difference is still the same in these two. That's obvious actually. We're adding 2 numbers each side and subtracting them, we'll get obviously the same number. And if we get the same value by subtracting the second term from the third term, then we can prove that this whole thing over here is an AP. So let's subtract the second term from the third term. We get the same d. A cancel out, k cancel out, and 2d minus d, we get d. Similarly, this whole sequence over here is in AP. It's in arithmetic progression. Now this is our addition, and subtraction is the same too, because k, if you want to take subtraction, just take k as negative, and if you want addition, then k is positive. So k can be both positive and negative. Okay, so that is our first property. And the second property, each term of an arithmetic progression is multiplied or divided by a non-zero constant quantity, then the resulting sequence form an arithmetic progression. So it's the same logic, it's basically the same logic over here. Let me just increase the size. Wait a second. Okay. A k. So I'm directly writing it like a into k, first term into k, plus a plus d. Wait, a plus d whole into k, whole into k, comma a plus 2d whole into k, and so on. A plus n minus 1 and minus 1 into d. Let me just start the brackets over here. Whole into k. So this is a series over here. Sequence, whatever. Yeah, sequence. Arithmetic progression. It's a progression. Now this too is an AP. How? Just subtract the first term from the second term. You get AK plus DK minus AK. That's DK. So the first term, second term minus first term is DK. Now let's D into the K. My different common difference into the constant K. And now subtract the second term from the third term. You get AK plus 2DK minus AK plus DK. You're gonna get the same DK over here. So let me just write that over here. Okay. So from this you get first of all the second term minus first term. I'm gonna write the second term. The second term is AK plus DK minus, we're gonna multiply this, we're gonna subtract this AK, sorry, and the AK cancel out, we're gonna get DK. So DK is the common difference. Now we're gonna subtract the second term from the third term, and the third term is, let me just move that up. Okay, the third term is AK plus 2DK. AK plus 2DK. AK plus 2DK. Minus the second term, which is AK plus DK. And don't forget to keep the brackets over here. And if we multiply that with minus 1 inside the bracket, the positive AK and the negative AK, so this is going to be multiplied by minus 1, and this is going to become minus DK. So this minus DK and this 2DK will not cross out, 1 DK will go, and we're remaining with the same DK, which is our common difference. Now that's with multiplication. Or if you want division, then K will be just its inverse, like 1 by K. So that's for the second property. Now let's go to this third property. Sum or difference of two APs is also an AP. If we have like say 1, 2, 3, 4, 5, so on, and our next AP will be 2, 3, 4, 5, 6. This is our AP over here. Now we're just gonna add them, and if we add them, we're gonna get let me write this in a different color. So let me just change its color to say yellow. Just wait a second, and change it to pink. Okay, like 2, 3, 4, 5, 6. And I'm just gonna add this. We're gonna get something like this. What we're gonna get is 3 comma 5 comma 7 comma 9 comma 11. This is our AP that we get after we add these two APs. So this is also an AP with common difference 2, and the first term 3, and that's another AP, and the difference is same. It goes like that. So just I'll show the example for difference too. Like we'll go wait a second. Let me take another example. 4 3. Oh shit. Like that. Okay. 5 comma 4 comma 3 comma 2 comma 1. So in this I'm showing that D should not always be positive. There's no such rule that the arithmetic progression was always increasing but never decreases. So D can be negative over here, and here you can go to the nth term can go negative, but minus nth term does not exist. So there are no minus terms. So there are nothing like minus 1th term. Nth term can be minus 1, but there is no such thing as minus 1th term. So the terms will be always positive, like t1, t2, t3, t4, and so on, tn. You don't get t minus 1, t minus 2, we don't get that. But the terms can be negative. And another 4, 3, 2, 1, and 0. Our GP over there. AP, sorry. And we're going to subtract that. We're going to get 1. Just a second. We're going to get 1, 1, 1, 1. Oh, wait. 1, 1, 1, and 1. And we'll get 1 for infinity, of course. Now this is an AP because a progression is a sequence. A progression is a sequence which has pattern in it. So a progression is a sequence, but a sequence is not a progression. So in a sequence over here, as we see, repetitions are allowed. So this over here is an AP here, 1 1 1 with common difference D, first term 1, last term 1, and every term 1. Okay, so that's with our third property. Now let's go to the fourth property, and this property is nothing about the topic, but it is helpful for solving problems. Like it's very easy. So like we are given in the question, like we have 3 terms, their sum is this and their product is this. So we shouldn't take this. We could take it, but it will be difficult for us. We should not take a plus d, a plus 2d. So we have to find a and d. So mostly we'll get 2 equations, the sum and the product. So multiplying these binomials and monomials will be tough. So rather than this, you can just take a minus d, a, and a plus d. Now this will be easier to calculate. Wait a second. This is easier to calculate. So if you're given their sum, you can just the d cancel out, and 3a equals to whatever their sum. And if you have to multiply, a into a square minus d square, so that is a cube minus ad square. So that will be easy to calculate. And similarly for 4 terms, you can take this thing over here, a minus 3d, a minus d, a plus d, a plus 3d. So observe a pattern here. You have to take such terms, you have to denote the terms in such a way that it shouldn't get more complicated as you go into the problem. Like if I add this thing, I'm just gonna get 4a, all the d's are gonna get cancelled. Then it will be easier to work. So I can find a very quickly. I know the sum, I have these 3 terms, and if I take a plus d, a plus 2d, a plus 3d, and I add them, I would have to find a and d. It will be difficult. I have to use a linear equation with 2 variables. But if I take this over here and I add this, I'm gonna get 4a equals to whatever the sum is, and a can be found easily, and from a, d can be found easily too. Now let's go to the 5th property. in AP, Tn equals to Tn minus k plus Tn plus k by 2 for k less than or equal to n. Now this formula over here is useful for solving problems, and the arithmetic mean 2b equals to a plus c also came from here and originated from here, this formula. So let me show you how the arithmetic mean actually came from here. So I have three terms, a comma b comma c, and a is my first term, b is my second term, and c is my third term. Now Tn, so I'm gonna find Tn. I'm gonna take n as 2, so I want my second term, which is b. So that is like b equals to Tn minus k, so k is 1. So k should be less than or equal to 1. Less than or equal to n, sorry. And in this case, it's 2. So why should k be less than n? If it's greater than n, you're gonna get t minus 1, t minus 2, and t, the negative term. So there are no negative term. And it can be equal to though. No, b equals to k is 1. I'm taking k as 1. T1, which is a. T1, sorry, a. Plus Tn plus k. T2 plus 1. T3. T3 is c. So b equals to a plus c whole divided by 2. So I multiply both sides with 2, you get 2b is equal to a plus c. So that's how you get the arithmetic mean formula from this. Now this is our last property over here, which is a1, a2, a3, and so on, a, n, b, and ap. Then the first term plus last term equals to the second term from the starting and plus the second term from the beginning, plus a equals to a3 plus a n minus 2, and so on. So it's saying that if I have my AP over here, say 1, 2, 3, 4, 5, 6. It's telling that 1 plus 6 equals to 2 plus 5 equals to 3 plus 4. And it's taking T1 plus T2, T1 plus Tn, T2 plus Tn minus 2, like that, n minus 1, sorry. So this is actually the way we find the sum of two opposite sides in a dice. Like there are 6 numbers, 1, 2, 3, 4, 5, 6, all of them should be equal, like 1 plus 6, we remove that, and 2 plus 5, and we take that out, and 3 plus 1. Now you might get a doubt, here I took even number of terms, that's why I have 2 middle terms and I can add them. So what if I had odd number of terms, like 1, 2, 3, and 4, 5? Then this general form plays a good role. I have 1 plus 5, that's 6. We have 2 plus 4, that is also 6. And what number should we add 3 to? Now this comes in. Now which term is 3? It's the third term, so a3 plus a n minus r plus 1. The value of n is 5, the number of terms. R is 3, so a n minus r, a2 plus 1. So that's nothing but ar plus ar. So that is a3 plus a3. We have to add 3 to itself. So that's going to be 6. So in an odd number of terms, if there are odd number of terms in an AP, then there is always a one middle term. How? The general form of expressing an odd number is 2n plus 1. So if I remove n terms from the last and n terms from the beginning, that would be 2n plus 1 minus n minus n. So I would be remaining with the 1, and the 1 will be in the middle. So in this case, 2n plus 1 equals to 5. Number of terms equals to 5. So 2n plus 1 equals to 5. Let me write that down. 2n plus 1 equals to 5. And from this we get 2n equals to 4, n equals n, 2n equals to 4, n equals to 2, right? N equals to 2. So I'm going to subtract 2 from both the last and the first. So if I subtract, remove 2 terms, this is first 2 terms are gone, second 2 terms are gone, and we got this third term, which is the middle term. Now in the event, so let me express this. So if there are 2n plus 1 terms, the n plus 1 plus 1 by 2th term. So if I have n terms, let me write that down. I have n terms and n is an odd number, then the middle term will be n plus 1 by 2. So I have 5 terms, 5 plus 1 6 by 2. The third term will be the middle one. So the odd term, the middle, okay, the middle term in odd equals to n plus 1, the whole divided by 2. What if even? N even. So just move that over here. So this is our even AP over here, even number of terms AP. So here the middle term is 3, 4. So 3 is half the number of terms. So that will be n by 2, and by 2, comma, equals n by 2, comma, the term after it. That will be n by 2 and divided by 2. This is different. N by 2 plus 1th term plus 1. So this is the middle term. You can note this down, and there's a problem coming up. So let's check it out. So an AP consists of even number of terms, 2n. So it's not n, it's 2n. So it's already showing that it's even in 2 ways. It's telling even, and the number of terms is 2n. So having the middle terms equal to 1 and 7 respectively. And I show the general formula of the middle terms in even numbers on the previous slide. You can go back to check it out. If n is the maximum value which satisfies this equation over here, t1 into t2n plus 713 should be greater than or equal to 0. Then the value of the first term of the series is, so now remember that 2n is the last term. Don't go like the last term is always tn. It could be t2n if the value of n is 2n. So I'm gonna give you exactly 1 minute to solve this problem. So 1 minute, 1.5 minute. Okay, I'm gonna give you 1.5 minute, and the time starts now. Only 30 seconds remain. You can pause this video for extra time if you are a beginner. recording stops now. So 1.5 minutes have passed, and let's see how many of you have solved. Just comment in the comment section below that you have solved the question in 1.5 minutes only. Okay, now let's see the solution. So these were the options, like A was 17, B was minus 15, C was 21, D was minus 23. Now let's look at the solution. Now given the middle terms, Tn equals to 1 and Tn plus 1 equals to 7. But this does not look as I mentioned. What did I mention in the previous slides? I said that the middle term was n by 2, but here it's only n. That's because the number of terms is not n, but it is 2n, and 2n by 2 is nothing but n. And the term after it, Tn plus 1. So we know Tn equals to 1 and Tn plus 1 is 7. Now we're just going to add this. Tn plus 1 equals to 8. Now I'm going to show you a property, this property. Do you remember this? A plus a1 plus an equals to, and all of this thing, you know that? Now in this even AP, so you'll get a clarity once I take an example. I have 1, 2, 3, 4, and 5, and 6. Now here, some of the middle terms. This is Tn, this is Tn plus 1, and this is 2n. And 3 plus 4 is 7. And 1 plus 6 is also 7. So that's Tn plus 1 equals to 8, which is equal to the first term plus second term. So first term is T1 and the second term is 2n. Don't forget that the last term is 2n. It might be confusing for beginners. So that's our first equation. That's what we got. And now we're going to find the common difference, because the middle terms should be always consecutive. If there are two middle terms, then there should be always consecutive. If there are even number of terms, the middle terms will be always consecutive. And the difference of two consecutive difference of two terms in an AP is always a common difference, like T2 minus T1. First term second term minus the first term. So we're gonna get the 6 as D. So common difference of the AP is 6. And we know that Tn plus 1 is 8. Now we also know the general formula for the nth term and for the n plus 1th term. So just write that out. So a plus n minus 1 into d is for the nth term. So I'm just make box around it. So Tn, make it in black. So Tn, the same color means they're related to each other, they're all the same. If wait a second, just make that big, nice. Okay. Wait. Box around it. Tn, and this Tn over here, and this whole thing up to here is the same. And this Tn plus 1, this Tn plus 1, and this thing are the same. Now I add these. So a plus nd. How did I get a plus nd? Just substitute n plus 1 in the value of n, and plus 1 minus 1 cancel out, and you're going to get a plus nd equals to 8. And you're going to simplify that. You're just going to add it, keep the value of d as 6, and you're going to get a plus 6n equals to 7. A plus 6n equals to 7. So you have the first equation. You need a second equation to solve this. Now we should all know this thing. This 4ab equals to a plus b whole squared minus a minus b whole squared. So if you're going to simplify this, so let me just prove this over here. What's going to happen, you're going to get a squared from here, and you're going to get a squared from here too, but it's multiplied by minus, and the a squares cancel out. Similarly, the b squares cancel out too. And here you have a positive 2ab. So you have a 2ab here, and you have a minus 2ab here, and minus 2ab multiplied this by this minus makes plus 2ab, and you got like plus 2ab and plus 2ab, that makes 4 2ab. So this is not related to sequence and series. That this formula over here we should know from the beginning, and that's the strategy. We know we need more ways to solve. So 4t1 t2n equals this. Now we're writing from here over here. T1 plus T2n is 8, as we know that. T1 Tn plus T1 n plus 1 is 8. 1 plus 7. So all are the same. 8 squared minus T2n minus T1 whole squared. Now I took T2n minus T1 whole squared as 6 into 2n minus 1. And how did I get that? It's from here. As I know that T2n minus T1 is 2n minus 1 into 6. And how did I get that? It's just a general term over there. We're going to find the general term for 2n. For Tn, it's a. The general term for T1, the first term, is a. And the 2nth term, that is a plus 2n minus 1 into d. And d is 6. So the a's cancel out when I subtract T1, and we're remaining with this, and you're going to substitute that, and you're going to square it. You're going to get 36 into 2n minus 1 whole square. So we have a 4t1 t2n over here, and the 4's cancel out, so we're going to divide both sides with 4, and t1 t2n equals to 16 minus 9 into 2n minus 1 whole square. And we just simplify it, because what is given the question, we need to find this t1 t2n. We got the value. If we add 713 through this, it should be positive or equal to 0. So that's what I just did over here. I added 713 and the condition, apply the condition, it should be greater than or equal to 0. Then if I solve this quadratic equation that I get here, we're gonna get the values of n like this. Like we're gonna get this period over here, minus 4 less than or equal to n less than or equal to 5. And I took n equals to 5 because in the question it asked if n is the maximum value. It should be the maximum value that satisfies that equation, and the maximum value that satisfies that equation is 5. So if I take n equals to 5, and we should not tick the option saying 5, I didn't give that option, but sometimes in some exams the option 5 may be there to trick you, but never tick that. The purpose we found n was to solve this equation over here, a plus 6n equals to 7. Just substitute 5 in that, and you're gonna get a plus 35 equals to 7. A plus 35 equals to a plus 30. A plus 30 equals to 7. Sorry, a plus 30 equals to 7, and you're gonna find a is minus 23. That's our answer. This is our answer over here, minus 23. Okay, now this is your homework question. Just I'm gonna read it out for you. Let a1, a2, and so on, and b1, b2, and so on be the arithmetic progressions such that the first term of the a series is 25 and the first term of the b series is 75, and a100 plus b100 equals to 100. The 100th term in the a series plus the 100th term in the b series is 100 sequence. Then the sum of the first 100 terms of the progression is, so this is your progression over here. This is your progression over here. You're gonna find the sum of the first 100 terms, so that's S100 for this. I gave you the formulas related to this. You know everything about this now. We're just gonna solve it, and I'll be reading out the names of the first 5 people who give the correct answer in the comment box below. So you can just pause this if you want the question. And bye. One Math Army will meet you again soon. Till then, bye bye, and don't forget to subscribe to the channel, and if you liked it, like the video, hit the like button and share it with your friends to make this popular. Soon I will start streaming live and conducting quizzes and everything. So goodbye, and I also can make this video in Hindi, so just ask me in the comments. So which state syllabus maths you want to start first, you want me to teach, just give it in the comments, and I will be picking a comment and following that. So it's like if someone comments speak in Hindi, I'm gonna make another video like this in Hindi, and if someone says make the state syllabus of Andhra Pradesh, I'll make that. So give your suggestions what I should teach next in the comments below. I will be continuing this in a few hours or day. Okay, bye.